Chapter 6, Part 4, Factors Affecting the Rates of SN1 and SN2 Reactions. We're going to start with discussing the structure of the substrate. Now, there are several factors that affect the rates of SN1 and SN2 reactions. These factors also dictate what mechanism a reaction is more likely to occur through. So, in order of priority, the structure of the substrate is probably the most important of all of these factors. For an SN2 reaction, any methyl substrate is more likely to undergo an SN2 reaction. Same with primary. A tertiary substrate is definitely going to undergo SN1. A secondary substrate is kind of the only gray area for SN1 and SN2. So from there, you look at the strength of the nucleophile. SN2 requires a strong nucleophile, while SN1 needs a weaker nucleophile, or can occur with a weaker nucleophile. The next thing to look at is the leaving group identity. From there, you can also look at the concentration of the nucleophile. And then lastly, you can look at the solvent. So the first factor is the structure of the substrate. And I already went through this kind of briefly, but we're going to talk about why a little bit. So again, for SN2, methyl substrates are definitely undergoing SN2 reactions. And the reason why is the steric effect. There's a term that we've kind of used lightly without providing too much definition for at least the past 2 chapters, which is steric hindrance. Steric hindrance is when the spatial arrangement of atoms or groups at or near a reaction site slows or hinders the reaction. Or, the much more straightforward definition, when there's too much stuff in the way. So, for example, a neopentyl halide is technically a primary alkyl halide, which, according to our little chart here, says that it should be SN2. And it's going to be kind of highly favored in the world of SN2 because it's towards the top of the list. But neopentyl halides tend to be fairly unreactive in SN2 situations because the backside attack is blocked by the fact that this group is quite large. There's a lot of electron density there, and so it's unlikely that a nucleophile will come in and attack at this position, especially since it needs to come from here so it can kick out the halogen. For an SN1 reaction, you want more substitution. So a tertiary substrate, SN1. A secondary substrate, SN1 is highly possible. And the reason why is carbocation stability. In an SN1 reaction, we're going to go through a carbocation. Methyl carbocations do not form very easily, which is why methyl is down here at the bottom. A primary carbocation tends to be pretty unstable. Good carbocations include tertiary, which would be the best, and secondary. So your tertiary and secondary ones are pretty likely to do SN1 chemistry. And that's because the lower energy carbocation intermediate will be formed. There are a couple special cases of unreactive alkyl halides. These are alkyl halides that have sp2 hybridized carbons. These are not going to be receptive to substitution reactions. So this includes alkenyl halides and phenyl halides. And again, that is because of the SN2 carbon that the halogen is on. Neither of these can form carbocations very easily, nor can they be attacked by nucleophiles.